All right, so I'm gonna go over the vision story and I'm gonna annotate. So while I'm going over the story, I'm gonna annotate. This is the dark reaction and this is the light reaction. So in the dark, the cone becomes more positive. So the first thing is we're in the dark. The second thing is the cone becomes more positive. And as a result of that, there's more transmitter glutamate released to the on center and off center bipolar cells. If you are doing this and trying to remember, always remember that on center the on center bipolar cell is metabotropic. So it's metabotropic glutamate receptor. And so the first thing that happens is that the glutamate gets released. And then when the glutamate is released to the on center bipolar cell, the metabotropic glutamate receptors are inhibited. So they're not going to be working properly. So the on center bipolar cell is not going to be releasing transmitter to the on center ganglion cell or less transmitter. And then the on center does not fire action potential. So in the dark, the on center is not firing action potentials. So for the other part of this is when a lot of glutamate is being released, remember, this is the only one with metabotropic glutamate receptors, aka G protein coupled. And for the off center, we have for the off center, there is a ligand gated and also this on center ganglion cell. But for all the other ones are ligand gated, and this is the only on center bipolar cell is the only one that has metabotropic glutamate receptors. So after knowing that information, the glutamate is being released to the off center bipolar cell. The glutamate is going to attach to the ligand gated, and then it will release, there we go. It will release more so the cell becomes more positive. So the cell releases more transmitter, and the off-center ganglion cell is going to fire more action potentials, signaling that the brain is in the dark. So in the dark, remember that the off-center are the cells that are firing. And in comparatively in the light, the on center cells will be firing. So let's go to the light story. Okay, step 1, we're in the light. Step 2, we're becoming more negative because we are in light, we're getting more negative. So in the dark, we're at about negative 35. We're more positive. We're more positive in the dark. And when we are in the light, we're more negative. So being more negative, we release less glutamate. And the decrease of glutamate means that these inhibitory these inhibitory metabotropic glutamate receptors are not being inhibited. So they've been relieved of inhibition. And so what that means is the on-center bipolar cell is going to release more transmitter. It becomes more positive. It releases more transmitter. And then as a result, the on center becomes more positive, and we fire action potentials. When less glutamate is released to the off center bipolar cells, they aren't going to be, they're going to become more negative and therefore release less transmitter. And then the off center ganglion cell is gonna become more negative and therefore not fire action potentials. So, oops, I'm gonna undo that. So we can see from this that when we're in the dark, we're firing the off center and off center cells. Those are the ones that are getting more positive and firing action potentials. And in the light, it's the opposite. So in the light, the on center cells are going to be the ones that are becoming more positive and therefore creating action potentials. So this is the best way that I could explain it, and I hope it helps. All right, thanks.